Today we're going to spend some time talking about adding and subtracting radicals. So last class you learned about multiplying radicals, and today we're going to talk about adding and subtracting radicals. Adding and subtracting radicals are the most picky because it's just like combining like terms. In the beginning of the year, we talked about combining like terms, where if I had 2x plus 3x, I was allowed to say that equals how many? 5x. But if I had 2x plus 3y, I was not allowed to say 5xy because these are not like terms. In order for things to be like terms, I have to be able to add them together. So if I had 2x plus 3y, my answer would not be 5xy. Now it's loading. My answer would just be 2x plus 3y. So adding and subtracting radicals is just like combining like terms. So if I have an example and I have 2 times the square root of 3 plus 3 times the square root of 3, because my radicals are the same, I'm allowed to add them together. So I would just add my coefficients together. 2 plus 3 is 5. I have 5 rad 3. If I had 5 rad 7 plus 5 rad 3, notice my radicals are not the same. I have rad 7 and I have rad 3, so I'm not allowed to add them together. So my answer would just be 5 rad 7 plus 5 rad 3. If I had 2 times the square root of 3 minus 4 times the square root of 3 plus 8 times the square root of 2, if we look at them, the terms that are the same, that have the same radical, are these two. So I can add those coefficients together. 2 and negative 4 make negative 2 rad 3, because that's just like saying 2x minus 4x. But notice 8 rad 2, I'm not allowed to add together because they don't have the same radical. So I just put it at the end, plus 8 rad 2. So if we go ahead and we try one more, if I have 4 rad 5 plus rad 5 minus 2 rad 5, what would that equal? Well, I'm allowed to add these three together because they all have the same radical. But notice this radical right there does not have a number in front of it. So what number is hiding? A 1. So now I'm going to add my coefficients. 4 plus 1 is 5. 5 and negative 2 make 3. So I have 3 rad 5. That would be my answer. So what would happen if I kept getting problems that looked like this? What if I had 4 rad 2 plus rad 8? Am I allowed to add these together? No, because this has a rad 2 and this has a rad 8, which means they're not like terms. So the main question is, well, what's going to happen if that's the case? Well, if that's the case, I have to look at both my radicals, and I have to first make sure that they're in simplest radical form before I can add or subtract. So if I look at the square root of 2, the square root of 2 cannot be simplified. But now let's look at the square root of 8. If I write all my perfect squares down here, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 64. Nope, I forgot 49. 49, 64, 81, 100. I just stop here, and then if my numbers are big enough, I can go further into my perfect squares. So the square root of 2, I can't divide any of my perfect squares into 2. So that's already in simplest radical form, so I'm just going to bring it down. So now I'm going to look at the square root of 8. 8 falls between 4 and 9. So can 4 go into 8? Sure enough, 4 can go into it 2 times. Square root, what's the square root of 4? 2. The square root of 2 I can't do, so I leave square root of 2. And I bring that sign down. Now, if I look at my what I have 4 rad 2 plus 2 rad 2. Notice my rads now match, so I can go ahead and add them up. So 4 plus 2 is 6 rad 2, and I'm done. So you might want to write a note to yourself is that radicals must be in simplest form before you add or subtract. Okay? Radicals must be in simplest form before you add or subtract. And if you go back and you look at all of these problems that we just did, 3 and 3, that's the smallest number because that number is prime. So when that number inside is prime, you can definitely not simplify it anymore. 7 and 3, I couldn't simplify those. 3, 3, and 2, I can't simplify those. Those are all prime numbers. Remember, in order for something to be prime, it's only able to be divisible by 1 in itself. So because those numbers are so small, I can't break anything else up into it. So let's go ahead and let's try another example. I'm going to erase this. So I have space. So let's try 5 square root of 2 minus square root of 12. So before I circle this and say that's my answer, you look at the square root of 2. Can you simplify that anymore? No, because it's a prime number, so I'm just going to bring it down. Now look at the square root of 12. Well, let me see if the square root of 12 can be simplified. So 12 falls between 9 and 16. Can I do 12 divided by 9? No. Can I do 12 divided by 4? Sure enough, I can. So 4 and 3, square root, square root. What's the square root of 4? 2. Square root of 3, can I do that? No, so it stays 2 rad 3. And now bring down the minus sign. So now look at my radicals. They're both prime, but can I subtract them together? No. Why not? Because the radicals aren't the same, so this is technically my answer. I'm done. So some of you might be wondering, well, if I'm done here, why couldn't I leave my answer up here? And the reason why is because this up here is not in simplest radical form. I had to simplify the square root of 12 before I could say I was done. Let's go ahead and let's look at another one. To make life a little easier for us here. Let's do the square root of 45 minus the square root of 20 plus 2 rad 5. So if I look at the square root of 45, 45 falls between 36 and 49. Can 36 go into 45? No. How about 25? No. 16? No. What about 9? Yep. 9 and 5, square root, square root. So the square root of 9 is 3. Square root of 5 I can't do. So now I'm going to simplify the square root of 20. 20 falls between 16 and 25. Can I do 20 divided by 16? No. Can I do 20 divided by 9? No. What about 20 divided by 4? Yep. 4 and 5. Square root, square root. The square root of 4 is 2. The square root of 5 is rad 5. There's a minus sign, so it gets brought down. Now if I take a look at 2 rad 5, I know I can't simplify that anymore because 5 is such a small number, I'm not going to be able to break it down. So 2 rad 5, bring that plus down. So now if I look at all my rads, do they match? You betcha. So add up my coefficients. So 3 and negative 2 and 2. 3 and negative 2 make 1. 1 and 2 make 3. So I have 3 rad 5. And finish. If I do one more with here, what happens if I have a variable in the mix? Same thing as before with combining like terms. 5x plus 2x 2xy. Am I allowed to combine these two together to make 7xy? No, because this guy over here doesn't have a y. Okay? So it's just the same exact concept. So I'm going to do 2 times the square root of 125x squared z plus 8x times the square root of 80z. So, okay, 125 is greater than 100, which is my biggest perfect square, so I'm going to keep going. All right, cool. So if I simplify 125 falls here. 121 can't go into 125. 100 can't go into 125. What about 125 divided by 81? Nope. 125 divided by 64? Nope. 125 divided by 49? Nope. 125 divided by 36? Nope. What about 125 divided by 25? Yep. 25 and 5. Square root, square root. The square root of 25 is 5. The square root of 5 is rad 5. This 2 has to come down in front. And remember what operation is hiding between those two? Multiplication. Now let's look at my variables. Because it's a square root, I'm dividing by 2. So if I take my exponent, which is 2, and I divide it by 2, I have 1x on the outside. If I look at z, I can't divide z, so he stays inside. So this would then clean up to 10x square root 5z. If I do my last one, 80 falls here. 80 divided by 64 doesn't work. 80 divided by 49 doesn't work. What about 36? Nope. What about 25? Nope. What about 16? Sure enough, it does 5 times. Square root, square root. So I have 4 rad 5. This z can't break out because I can't divide it by 2. And I have to remember to bring 8x in front. The operation between those is multiplication because it's invisible. So I have 32x times the square root of 5z. I have my plus sign. Bring it down. So now the million-dollar question of the day. Am I allowed to add this with this? Yes, I am, because I have a 5 and a z on the inside, and I have an x on the outside, so I can combine my terms. 10 plus 32 makes 42x, 5z. Okay? So I'm going to give you 2 problems that I want you to try on your own. And when you finish, I want you to bring them to me so I can check them. So you're going to do these 2 problems. 5 rad 7 minus 2 rad 28 plus 6 rad 63. And you're going to do the square root of 20x squared minus 3x rad 5. One thing I want to quickly mention is in this video, we did only discuss square roots. I can do this with cube roots as well. I'm just not obviously able to add the square root of 2 plus the cube root of 2. I couldn't add those together. That would be in simplest form and would be my answer. But if I was doing this with a cube root, I would be doing it the exact same way, just with a square root, or just with a cube root versus a square root. So once you finish these 2 problems, bring them to me and I will check them.